So today I'm going to start chapter 12. Excuse my voice, I'm sick, but I'm trying to do my best considering the circumstances. So chapter 12, it's more on systems of equations. So in 12.1, I'm going to go over solving systems of two equations in two variables. Solving systems of two equations in two variables. There are three methods for solving systems of two equations. The first one is the graphing method. So if we have a system of two equations, how do we solve it by graphing? We have a handout, it's in the notes. Graphing method for solving systems of two equations. You graph both lines on the same rectangular system of coordinates. If the lines intersect, you have one solution. So you could have intersecting lines where you would have one solution and the system is independent. You could have parallel lines where there is no solution and the system is inconsistent. And you could have the same line where you have infinite solutions and the system is dependent. So if you graph the two lines, they intersect. That point of intersection is the solution, and there's one solution, and we say the system of equations is independent. If the two lines never intersect, we have no solution, it's an inconsistent system. If they are the same line, you have infinite solutions and the system is dependent. Okay, this is the graphing method for solving systems of equations. Number 22, page 1015. Solve by graphing. (3x minus y equals -3), y equals -2x minus 7. So we're going to have to graph each line separately. So let's start with the first line. Each line we're going to make a t-table. If x is 0, then you get -y equals -3 and y equals 3. If y is 0, then you have 3x equals -3, x is -1. And you need graphing papers to get decent answers. 0, 3 and -1, 0. So this is the first line. Then the second line, y equals -2x minus 7. Again, let's make a t-table. When x is 0, y is -7. When x is -1, you get 2 minus 7 is -5. So 0, -7, -1, -5. And they do cross. If you have good graphing papers, you're going to see that they cross at -2, -3. And to check your answer, you plug it in. 3 times -2 minus -3, does that equal -3? -6 plus 3, that does make sense. Let's try here. -3 equals -2 times -2 minus 7, 4 minus 7, which is good. Okay, here's another one that I want to do. So when we do graphing, we're gonna have graphing papers so we can see exactly where they are, unless they are non-integers. If they are non-integers, then graphing is not good. We're gonna be able to see across. That's why we're gonna consider elimination and substitution. So number 26, how do we graph? Solve by graphing. X equals 5 minus 2y. 3x plus 2y equals 7. Well, let's start. We gotta be a little clever picking the points because we don't want any fractions. Well, if x is 0, it's okay, it's not that bad. So you get 2y equals 5, y equals 2.5. And if y is 1, 3x is 5 minus 2, 3x equals 3, x equals 1. I picked 1 because 5 minus 2 is 3, which is divisible by 3, just to make my life easier. So 1, 2, 3, 0, 2.5, and then 1, 1. And this is the first line. Second line, 3x plus 2y equals 7. Again, let's make a t-chart. So if x is 1, then that would be 3 plus 2y equals 7, 2y equals 4, y equals 2. And if x is 0, then y would be 3.5, which is not bad. 1, 2, 0, 3.5, 1, 2, 3, 4, 3.5. So it looks like the two lines are parallel, meaning we have no solution and the system is inconsistent. Alright, so again, you can see the problem with graphing. If cross at non-integer, like if this is 1 and this is 2 and the value of falls somewhere. So this is, although it's visual, it's nice, but it's not the best method. So we're gonna talk about two algebraic methods, the second and the third. The second one is the substitution method for solving systems of equations. And when do we actually, if we have a choice, we should be used if one of the variables, whether it's x or y, is isolated or can be easily isolated. So if you have x equal or y equal, that's automatically substitution method. And here's an example, and I'll go over the steps. X equals negative 2y plus 1. 2x plus 3y equals negative 1. Choose one equation and isolate one variable. This equation will be considered the first equation. This is already isolated. Substitute the solution for step 1 into the second equation and solve for the variable in the equation. So we're going to take all this and plug it in for x, and then solve for y. Plus 3y equals negative 1. Distribute negative 4y plus 2 plus 3y is negative 1. Add like terms, negative y plus 2 is negative 1. Subtract the 2, negative y is negative 3. So I have solved for that variable. Using the value found in step 2, which is y equals 3, substitute it into the first equation and solve for the second variable. So we're going to take y equal 3 and plug it into the first equation right there. Negative 2 times 3 plus 1. Negative 6 plus 1. Negative 5. And write your solution as an ordered pair. You can check your answer, but you don't have to. So this is called the substitution method. Here's another one. Solve by substitution. Two x minus y is negative 1. 4x plus 5y equals 7. So the easiest variable to isolate is this y on that equation. So we're gonna write, we're gonna add the y to move it over. So we get 2x equals y minus 21. Add 21. Y equals 2x plus 21. So we take all this and put it in there. So we have 4x plus 5 times 2x plus 21 equals 7. Distribute the 5. That's 10x. 5 times 21 is 105 equals 7. That's 4x 105 equals 7. It's minus 105. 14x is negative 98. 7 is 105 is negative 98. Divide by 14. X equal negative 7. Okay, so remember we're solving for x and y. So now we're going to take that and we're in the first equation. So we have x equals negative 7, y is 2x plus 1, plus 21. So 2 times negative 7, which is negative 14, plus 21, which is 7. And my solution is the ordered pair, negative 7, 7. Now sometimes solve by substitution. Sometimes you don't see a variable that's easy to isolate, which makes us suspect that this is not the best method the substitution method, maybe it's the elimination method. It could be the elimination method, but because we don't have one x or one y, if we want to isolate x or y, we're going to end up with a fraction. But what we can do, since we have 4x in both equations, we can isolate 4x. So the 4 is going to be isolated with this. If you look at the second equation, adding 2y, so you have 4x equals 5 plus 2y. If you divide by 4, you have a fraction, so we want to avoid that. So we're going to isolate the 4x. We're going to put 5 plus 2y into the other equation for 4x. So you're going to do 5 plus 2y. So 4x is 5 plus 2y plus 3y. It's just a little clever idea so we don't deal with fractions. Add like term. Subtract the 5. 5y is negative 10. And y is negative 2. Now we go back to the isolate equation. Y is negative 2. And we have 4x equals 5 plus 2y. So 4x is 5 plus 2 times negative 2. 5 plus negative 4 is 1. So x is 1 over 4. Okay. So far we've done graphing, which uses graphs to see how many solutions we have, and then substitution, which uses algebra to find the solutions, but it's good only if one of the variables is isolated or can be easily isolated. The third method is what we call the addition or elimination method. And this method should be best used if both equations are in general form and the coefficients of either x or y are opposites. That's ideal for using elimination or addition method, is both equations are in general form and one of them has 3y, the other has negative 3y. One of them has 2x, the other has negative 2x. Because as it says, we're going to add, and once we add, we're going to eliminate one of the variables. Okay? So here's an example. Four x plus 3y equals 1. 2x minus 3y. This is an ideal elimination question. If you look at the write both equations in general form, and they're already in general form. Multiply one or both equations by an integer so that one item has the opposite coefficients in the two. One term has opposite coefficients in the two equations. We already have that. Plus 3y minus 3y. So we don't have to times anything. Add the equations to produce a single equation with one variable. So we add like terms. That's 6x equals 12. We already have one solution. Substitute the variable back into one of the equations and solve for the other variable. So we're going to substitute it back into the top equation. 4 times 2 is 8 plus 3y is 1. 1 minus 8 is negative 7, so y is negative 7 over 3. And that's the answer. Okay. Solve by elimination. Elimination or addition, the same thing. 4x plus 6y equals 5. 8x minus 9y equals 3. So it looks like it's easier to get those values opposites than these. We're going to times the top equation by negative 2 to make it negative 8x because we already have an 8x. Let's do the math over here. So negative 8x, negative 2 times 6y is negative 12y, and then negative 2 times 5 is negative 10. The x's cancel out. Negative 9y plus negative 12y is negative 21y. And that's negative 7. 3 plus negative 10. Divide by negative 21. So 1/3. So go back and plug it in. 4x plus 6y is 5. 4x plus 6 times 1/3 is 2, is 5. So that's 3. And x is 3 over 4, and my solution is 3 over 4, 1/3. Okay. Uh, 4x plus 6y equals 5. 8x plus 12y equals 3. So if we times the top equation by negative 2 to eliminate x, we got negative 8x minus 12y is negative 10, and we get 0 equal negative 7. Remember, when there are two cases when we're solving a system of equations, either one solution which we get x and y, we've been doing this all along, no solution if it's inconsistent, so this looks like it's inconsistent. no solution. So if we graph the lines, they would be parallel. And if it was 0 equals 0 or 5 equals 5, that would be the case. The lines are the same and it would be dependent, okay? Here's more examples. 2x minus 3y is 7. 3x plus 2y is 1. Okay, so here we gotta times the top equation by 2 and the bottom equation by 3. So we get 4x minus 2 times 3y is 6y, 2 times 7 is 14, 3 times 3x is 9x, 3 times 2y is y, and 3 times 1 is 3. So 4x plus 9x is 13x, 14 plus 3 is 17. So x is 17 over 13. Now, if you do not want to plug it in and deal with fractions, we can do elimination again. Remember how we multiplied by 2 and 3 and we eliminated y? Now we multiply by 3 and 2, or 3 and negative 2, eliminate x. So let me show you, so that you don't have to plug in a fraction and deal with it. So if you rewrite the system of equations, 3x plus 2y is 1. So I want to eliminate x. I want to times the top one by negative 3 and the bottom by 2. So I will have negative 6x. Negative 3 times negative 3y is plus 9y. Negative 3 times 7 is negative 21. 2 times 3x is 6x. 2 times 2y is 4y equals 2. So we get 13y is negative 19. And we don't have to deal with the fractions. We got the answers. So x is 17 over 13 and y is negative 19 over 13. Alright, 74, page 1016. 74, page 1016. X over 2 minus y over 3 is negative 4. X over 2 plus y over 9 is 0. So we want to solve this system. So probably a good idea to just times this by negative 1. So it'd be negative x over 2 plus y over 3 is 4. So we have y over 9 plus y over 3 is 3y over 9 equals 0 plus 4 is 4. So we get 4y over 9 is 4 multiplied by 9 to get rid of the fraction. 4y is 4 times 9 is 36. Y is 9. And then you can just plug it in the top equation. X over 2 minus y over 3 is negative 4. Minus 9 over 3 is negative 4. Add the 3. X over 2 is negative 1 times by 2. X is negative 2. So negative 2, 9 is the solution. Okay. Couple more application questions. 4, page 1017. The function c of x equals 200x plus 400 gives the cost for a college to offer x sections of an introductory class, x sections of an introductory class in CPR. The function r of x equals 280x gives the amount of the revenue college brings when offering x sections. Okay, so revenue cost. Find the break-even point where cost equal revenue by graphing each on the same coordinate system. So we're gonna do it without graphing, break even. So C of x equals R of x, 200x plus 400 equals 280x. Subtract 200x. So 400 equals 80x. So the break-even point is 5 sections of CPR. Okay, find the break-even point, 5 sections. And if you want to see the cost for that, C of 5 is gonna be 200 times 5 plus 400. It's gonna cost $1,400. That's when they break even, because they are 5. How many sections does the college need to offer to make a profit with the CPR training course? Of course, they need to offer more than 5, because 5 will break even. So more than 5, the more they offer after 5, the more money they make. Okay. All right. Do one more. 104, page 1018. 104, page 1018. A retired couple invested part of 12,000 at a rate of 6% and the rest at 7.5%. If their annual income from these investments is 810, how much was invested at each rate? So it's about investment. So principal times rate times time equals interest, times rate times time equals interest. So there's 2 investments. Let's call them first and second. So we don't know how much was invested at each rate, X and Y. The rate is 6%, 7.5% for 1 year, and the interest 0.06x, 0.075y, and the total is 810, and the total invested here is 12 grants. So there's the 2 equations. X plus y is 12 grants, and 0.06x plus 0.075y is 810. So we have a system of equations. We can solve. The easiest method that I know is by substitution. So if we isolate y, that would be 12,000 minus x, and plug it in there. So we get 0.06x plus 0.075. 12,000 minus x is 810. Distribute 0.06x plus 0.075 times 12,000 is 900 minus 0.075 times x equals 810. Combine like terms. 0.06x minus 0.075 is negative 0.15x. 810 minus 900 is negative 90. So x is 6 grants. We have 6 grants at 6%. And y is also 6 grants because the total is 12 at 7.5%. And that's it for 12.1. I'll see you soon, 12.2.